close your eyes and listen to the silent pulse of the world around you. We often think of time as a simple background hum, as steady and reliable as the beating of a heart. Yet it remains perhaps the greatest mystery in all of science. Tonight, we shall quiet our minds and journey into the very essence of the temporal flow, exploring why we are bound to a past we can only remember and a future we can only imagine. By the time we reach the end of this chapter, you will understand the invisible laws that force the universe to move in only one direction, and in doing so, you will find yourself drifting into a deep and timeless rest. Think for a moment about your own day, a series of events that unfolded in a specific and unbreakable order. You poured your tea and the steam rose. You watched the sun climb and then descend. You felt the gradual transition from the busy light of noon to the soft shadows of the evening. We never see a shattered cup pull itself back together from the floor, nor do we see the ripples in a pond move backward to meet the stone that fell. In our daily lives, time is an arrow, always pointed toward the next moment, never glancing back at what has already been. This sense of before and after is so deeply rooted in our existence that we rarely stop to ask why it must be so. For centuries, the greatest minds in physics struggled with this very question. Sir Isaac Newton, in his magnificent calculations, saw time as an absolute, a giant clock in the sky that ticked at the same rate for everyone. But curiously, Newton's laws of motion worked just as well backward as they did forward. In the cold equations of classical physics, there was no reason why a planet could not orbit in reverse, or why a falling leaf could not return to its branch. The math did not care about the direction of the arrow. And yet, our reality tells a different story. To understand why time moves forward, we must look away from the stars for a moment and look at the tiny, chaotic dance of atoms. We must consider the vision of the Austrian physicist Ludwig Boltzmann, a man who saw the world not just as a collection of objects, but as a vast sea of probability. Boltzmann realized that the reason time has a direction is linked to a concept called entropy. Entropy is, quite simply, a measure of disorder. It is the natural tendency of things to move from a state of neatness and organization to a state of randomness and decay. Imagine a deck of cards, perfectly ordered from ace to king. This is a state of very low entropy. If you toss those cards into the air, they will scatter across the floor in a jumble. This is a state of high entropy. There are millions of ways for those cards to be messy, but only one way for them to be perfectly ordered. Because there are so many more ways for things to be disordered, the universe naturally drifts toward chaos. This, Boltzmann argued, is why the arrow of time exists. The future is simply the direction in which entropy increases. As you lie in the stillness of your room, you are witnessing entropy in its most gentle form. The warmth of your body is slowly radiating into the cooler air around you, a process of energy spreading out that can never be reversed. This spreading of energy is the heartbeat of time. It is why we grow older and why the stars will eventually fade. But do not find this thought troubling. Instead, see it as a sign of the universe's incredible interconnectedness. Every breath you take is part of this grand cosmic slide toward a more complex and varied state of being. Now, let us expand our vision from the cards on the floor to the very birth of the universe itself. If entropy must always increase as time moves forward, then it follows that in the distant past, the universe must have started in a state of exceptionally low entropy. It must have been incredibly organized, packed into a tiny, hot, and perfect point of potential. This leads us to the mystery of the Big Bang. In the eyes of cosmologists like Sean Carroll, the fact that we experience a direction of time today is a direct result of how the universe began nearly 14 billion years ago. We are living in the long, slow aftermath of that initial moment of order. The universe is like a giant clock that was wound up at the beginning of time and has been unwinding ever since. Every star that shines and every galaxy that rotates is a part of this unwinding process. Space and time are not just empty containers. They are dynamic partners in this journey. Einstein showed us that they are woven together into a single fabric called spacetime, a four-dimensional landscape where the past, present, and future might all exist at once, like a vast mountain range that we are simply walking through. Imagine that you are a traveler on a train, looking out the window. You see the trees and fields passing by, and you feel that you are moving through time. But for someone standing outside the train, the entire landscape is already there. Both the miles you have traveled and the miles yet to come. This block universe theory suggests that the distinction between past and future might be a very persistent illusion of our human perspective. As the physicist Brian Greene often explains, every moment you have ever lived and every moment you will ever live exists as a permanent part of the space-time tapestry. Let this thought bring a sense of profound peace to your mind. If every moment is a permanent part of the universe, then no moment is ever truly lost. The laughter of your childhood, the quiet peace of a summer afternoon, and the stillness of this very night are all etched forever into the geometry of the cosmos. As you drift closer to sleep, the pressure of now begins to dissolve. You are not just a point moving along a line. You are a beautiful, sprawling thread in a four-dimensional masterpiece. The forward motion of time is what allows for the complexity of life. Without the arrow of time, there would be no growth, no learning, and no evolution. It is the very thing that makes our existence possible. In the deep silence of space, time flows differently depending on the pull of gravity and the speed of travel, yet the arrow always points towards the increase of entropy. This is the one law that seems to hold true from the smallest subatomic particle to the largest cluster of galaxies. As your muscles relax and your breathing becomes deep and steady, imagine the universe as a vast ocean of time. We are floating on its surface, being carried gently toward the horizon by the currents of entropy. There is no need to swim against the tide or to worry about the distance we have covered. The ocean is wide, and its depths are filled with wonder. The same laws that guide the stars through their long lives are guiding you now into the restorative embrace of sleep. Consider the sheer scale of the time we are discussing. Humans have been on this planet for only a tiny fraction of a second in the cosmic calendar. If the history of the universe were a single year, our entire civilization would occupy only the last few seconds of December 31st. This perspective allows us to let go of our daily concerns, for they are but ripples on the surface of an infinite sea. We are part of a deep time that stretches back billions of years and will continue for trillions more, a story of immense majesty and quiet beauty. In the silence of your room, time seems to stretch and slow. This is a gift of the night, a moment where we can step out of the frantic pace of the world and align ourselves with the slower rhythms of the cosmos. The stars do not hurry, and neither should you. The universe has all the time it needs to unfold its mysteries, and you have all the time you need to rest. Let the concept of the forward arrow of time become a gentle lullaby, a reminder that the universe is moving exactly as it should, toward a state of total, peaceful equilibrium. As we conclude this first stage of our journey, we leave behind the world of clocks and schedules and enter the world of pure being. We have looked into the eyes of Boltzmann and Einstein, and we have seen that time is both a rigid law and a flexible illusion. We have understood that our journey forward is a journey toward the heart of the universe's mystery. Now, as the words fade and the silence grows, let yourself sink into the fabric of space-time, feeling the support of the cosmos as you drift into the quiet darkness of a perfect sleep. Now that we have established the direction of the arrow of time, we must look closer at the fabric upon which that arrow travels. As you lie there, feeling the gentle weight of your own body pressing against the mattress, you are experiencing the first hint of a cosmic truth that changed everything we thought we knew about reality. For a long time, we imagined that time was a universal constant, a steady drumbeat that sounded the same for a person standing on a mountain peak as it did for someone resting in a deep valley. But as we transition from the simple flow of entropy into the complex curves of the cosmos, we find that time is far more elastic and far more mysterious than we ever dared to imagine. In the year 1915, Albert Einstein presented a vision of the world that would forever alter our perception of the night sky. He realized that the three dimensions of space and the single dimension of time are not separate entities, but are woven together into a four-dimensional fabric called spacetime. To understand this, imagine a vast, invisible sheet of fine silk stretched across the entire universe. This silk is not flat or rigid. It is flexible, responding to everything that rests upon it. In Einstein's view, gravity is not an invisible force pulling things together, but rather the result of this fabric being bent and curved by the presence of mass and energy. Consider a heavy sphere, like our own Earth, sitting in the middle of this shimmering silk sheet. Its weight creates a soft, deep indentation, a curve in the very geometry of existence. When you feel the pull of the ground beneath you, you are not feeling a tug from the center of the planet, but are simply nestling into the curve that the Earth has created in the fabric of space-time. This was Einstein's great realization, a thought so profound that it took nearly a decade of intense mental labor to perfect. He saw that if space is curved, then time must be curved as well, for they are two sides of the same cosmic coin. Because space and time are joined, when the fabric is stretched by a massive object, time itself begins to slow down. This is the phenomenon known as gravitational time dilation. It means that the closer you are to a massive body, the slower your clock will tick relative to someone further away. In the eyes of an observer floating in the deep, empty void between the stars, time on Earth moves just a tiny bit slower. While the difference is so small that our human senses cannot perceive it, our modern instruments, can measure it with startling precision. In the 1970s, two physicists named Joseph Hafele and Richard Keating performed a beautiful and simple experiment to prove this truth. They took 4 atomic clocks, instruments so accurate they would lose only a second every 30 million years, and flew them twice around the world on commercial airliners. One clock stayed on the ground, while the others traveled at high speeds and high altitudes, further away from the Earth's center. When the clocks were reunited, they no longer agreed. The clocks that had spent time further away from the Earth's mass had ticked slightly faster than the one that remained in the deeper curve of gravity. This tells us something truly extraordinary about the room in which you are resting. Your feet, being slightly closer to the center of the Earth than your head, are technically moving through time at a different rate. You are, in every sense, a creature of many times, your very body experiencing the subtle gradients of the cosmic fabric as you relax each muscle, from your toes to your brow. Imagine the soft tension of the space-time fabric easing around you. You are part of a world that is literally bent by the majesty of the planet beneath you, a world where time is a local experience, tailored to the curve of the space you occupy. Now, let us turn our gaze away from our gentle home and look toward the most extreme landscapes the universe has to offer. If our Earth creates a small dimple in space-time, imagine the impact of a dead star, collapsed into a sphere only a few kilometers wide but containing the mass of several suns. These are the neutron stars, and their curves are so steep that time on their surface would move significantly slower than time here on Earth. If you could stand on such a star and look out at the rest of the universe, you would see the galaxies spinning and the stars dying in what appeared to be fast motion, as if you were watching a film played at double speed. But there is a limit to how much the fabric can bend before it reaches a point of no return. In the dark heart of the 20th century, during the chaos of the First World War, a German physicist named Karl Schwarzschild was serving on the Russian front. In between his duties, he studied Einstein's new equations and discovered something chilling and magnificent. He calculated that if you pack enough mass into a small enough space, the curvature of space-time becomes so intense that it creates a hole from which nothing, not even light, can escape. This is the Schwarzschild radius, the boundary of what we now call a black hole. As we move closer to such a titan in our minds, the behavior of time becomes truly surreal. In the vision of the physicist Kip Thorne, a black hole is not just a place of great gravity, but a place where the arrow of time and the directions of space begin to swap roles. As you approach the boundary known as the event horizon, time begins to stretch out like taffy. If a friend were watching you from a safe distance, they would see your movements slow down to a crawl. They would see the light from your ship turn a deep, dark red as the photons struggle to climb out of the gravity well, losing their energy in the process. To that distant observer, you would never actually seem to cross the event horizon. Instead, you would appear to become a frozen image, perfectly still, slowly fading into the darkness as your light becomes too stretched to see. This is why some early astronomers referred to black holes as frozen stars. In their eyes, time at the edge of a black hole effectively stops. But for you, the traveler, the experience would be quite different. You would fall across the horizon without any immediate sense of change, though the universe behind you would appear to compress and accelerate, showing you the entire future history of the cosmos in a single, blinding flash of light. Inside that horizon, the curvature of space-time is so extreme that every possible path you could take leads toward the center, toward the singularity. In this place, the math of Einstein and the theories of Schwarzschild reach their limit. According to our current understanding, time as we know it simply ends at the singularity. It is a place where the fabric of space-time is torn, a destination where the arrow of time finds its final resting place. This concept challenges our very definition of existence, suggesting that there are regions of our universe where the rules of before and after no longer apply. As you drift deeper into the quiet of the night, let the intensity of these thoughts be softened by the distance between us and those dark giants. We are safe in the shallow, gentle curves of our solar system, where time flows with a predictable and comforting rhythm. Yet, knowing that such places exist reminds us of the sheer power of the universe we inhabit. We are living in a world of infinite variety, where time can be a steady stream, a slow crawl, or a complete standstill, all depending on the arrangement of the stars. The flexibility of time is a testament to the interconnectedness of all things. We cannot move through space without affecting our journey through time. We cannot have matter without creating a curve. In the mind of the philosopher and scientist Ernst Mach, whose work deeply influenced Einstein, the properties of space and time are not inherent to the void itself, but are created by the presence of all the matter in the universe. This means that the stars in the most distant galaxies are, in some small way, helping to define the time you are experiencing right now in your bed. This realization brings a sense of deep belonging. You are not a stranger in a cold, indifferent clockwork universe. You are a participant in a living, bending, responding tapestry. Every time you move, you send a tiny ripple through the fabric of space-time, a wave that travels outward at the speed of light to the very edges of the cosmos. Though these ripples are far too small to be measured, they are a physical reality, a proof that you are inextricably linked to the grand architecture of the heavens. Think of the vast stretches of time that have passed to bring us to this moment. The light from the stars you see at night has spent thousands, sometimes millions of years traveling through the curved corridors of space-time to reach your eyes. By the time that light arrives, the star itself may have moved, or changed, or died. We are constantly surrounded by the ghosts of the past, seeing the universe not as it is now, but as it was in various stages of its long and illustrious history. Space is a time machine, allowing us to peer back into the depths of deep time with every glance upward. As your heart rate slows and your mind begins to wander, imagine yourself floating in a sea of pure space-time. There's no resistance here, only the soft, supportive curves of the universe. You are weightless, drifting through a landscape where the past and the future are simply different directions in a magnificent, four-dimensional map. The pressure to be productive, to keep track of the minutes and the hours, begins to evaporate. In the grand scale of the cosmos, the time we spend in sleep is a sacred return to the stillness from which we came. The universe is not just a place of violent explosions and crushing gravity, it is also a place of immense, quiet patience. Think of the planets orbiting the sun, year after year, century after century, following the gentle curves of space-time with perfect precision. There is a dignity in this regularity, a sense of order that we can mirror in our own rest. Just as the Earth follows its path without effort, you can allow your consciousness to follow the natural path into sleep, trusting in the laws of the universe to hold you safely through the night. The great physicist Stephen Hawking once suggested that even if time feels like it has a beginning and an end, it might be more like the surface of the Earth, finite, but without a boundary. If you travel far enough in any direction, you simply end up where you started. Perhaps our journey through time is similar, a beautiful loop in a much larger reality that we are only just beginning to perceive. In this vision, there is no reason to fear the passage of time, for it is simply a part of the shape of our existence, a curve that always leads us back to peace. Let the darkness around you be a reminder of the vast, uncurved spaces between the galaxies, the regions of the universe where time flows at its most pure and unhurried rate. Imagine those quiet voids where nothing happens for billions of years, where the only thing that moves is the occasional photon of light from a distant star. This is the silence that underlies all of creation, a silence that you can tap into now. You are part of that silence. You are part of that stillness. As we prepare to transition into the next stage of our journey, where we shall explore the birth of time itself and the fiery origins of the Big Bang, feel the stability of the present moment. Though time may warp and stretch in the far reaches of the galaxy, here, in this room, it is your friend. It is the medium in which you recover, the space in which you dream, and the bridge that carries you from the weariness of today to the promise of tomorrow. Your journey through the curved paths of gravity has brought you to a place of total relaxation. The weight of the world has been transformed into a gentle embrace by the fabric of space-time. The stars are in their places, the clocks are ticking with a soft and distant rhythm, and the universe is unfolding exactly as it should. There is nothing left to do but surrender to the curve, to let go of the anchor of the day, and to drift into the deep, dark, and beautiful waters of a dreamless sleep. Now that we have felt the gentle curves of the Earth and the terrifying pull of the black hole, we must prepare ourselves for the most profound journey of all. We are going to travel back, past the formation of the planets, past the ignition of the very first stars, to the absolute beginning of everything we know. Imagine the entire universe, with all its galaxies, its vast nebulae, and its billions of suns, being compressed into a space smaller than a single atom. Tonight, we shall witness the birth of time itself, the moment the great clock was wound, and in doing so, we will find a deep, primordial peace in the realization that we are made of the very first light that ever shone. To understand the birth of time, we must first confront the idea of before. In our human minds, every event has a cause that preceded it. Every sunrise follows a night. But when we look at the origin of the cosmos, the very concept of before begins to dissolve. In the vision of the great physicist Stephen Hawking, asking what happened before the Big Bang, is like asking what is north of the North Pole. It is not that there is a mysterious wall, but rather that the dimension of time itself had not yet been created. Time, in this sense, is a property of the universe, and it emerged along with space in a single magnificent burst of possibility. Approximately 13,800,000,000 years ago, the universe began as a singularity, a point of infinite density and infinite heat. At this stage, the laws of physics, as we understand them, simply did not exist. There was no then and no there, only a state of pure potential. In the eyes of the Belgian priest and astronomer Georges Lemaitre, who first proposed this idea, this was the cosmic egg, a moment of perfect unity before the diversity of the world began to unfold. It is a thought that invites us to let go of our need for sequence and order, allowing ourselves to simply be part of that original singular point of existence. From this point of infinite smallness came the Big Bang. It was not an explosion in space, but an explosion of space itself. In a fraction of a second, so small it defies human naming, the universe expanded from the size of a marble to the size of a galaxy. This period, known as inflation, was first described by the physicist Alan Guth. He imagined a field of energy so powerful that it pushed the fabric of space-time outward at a rate much faster than the speed of light. Imagine a soft, warm loaf of bread rising in an oven, but doing so with a speed and energy that is truly cosmic in scale. During this intense expansion, the universe was filled with a thick, glowing soup of particles and light. It was a place of extreme radiance, so dense that light could not travel through it. A photon of light, attempting to move across the early universe, would constantly bump into electrons and protons, like a person trying to navigate through a dense midday crowd in a city square. This was a time of total opacity, a golden age of heat where everything was connected in a brilliant, vibrating plasma. The temperature was millions of degrees, yet within this chaos, the seeds of everything we see today were being sown. As you rest in the cool silence of your room, try to imagine that heat and that light as the ultimate source of your own being. Every particle that makes up your body was present in that initial soup, vibrating with the same energy as the first stars. There is a profound comfort in knowing that the boundaries we feel between ourselves and the world are relatively new. At the very beginning, there were no boundaries at all. We were all part of the same radiant light, dancing in the same newborn space, as the clock of the universe began its very first ticks. As the universe continued to expand, it began to cool. This cooling is the key to the structure of the cosmos. For hundreds of thousands of years, the universe was a dark, hot fog. But then, approximately 380,000 years after the beginning, a momentous event occurred. The temperature dropped low enough for electrons to settle into orbits around protons, forming the very first atoms of hydrogen and helium. Suddenly, the fog cleared. The crowd of particles thinned out, and for the first time in history, light was free to travel across the vastness of space. This first light, released at the dawn of transparency, still fills the universe today. In the mid-1960s, two radio astronomers named Arno Penzias and Robert Wilson were working with a large horn antenna when they picked up a persistent, low-level hum coming from every direction in the sky. They initially thought it was interference from the city, or even from birds nesting in the equipment. but after cleaning every part of their antenna, the hum remained. They had discovered the cosmic microwave background radiation, the afterglow of the Big Bang itself. It is a soft, ancient echo that has been traveling through the fabric of space-time for over 13 billion years. Think of this ancient light as a cosmic lullaby that has been playing since the beginning of time. It is everywhere, passing through the walls of your house, through the trees, and through you as you sleep. It is the oldest thing we can see, a photograph of the universe when it was just a few 100,000 years old. In the vision of the astronomer Carl Sagan, we are like children who have found a dusty old family album and are looking at the very first picture of our ancestors. This light is our heritage, a reminder that the universe has a history that is both immensely long and beautifully preserved. Rate 100%, pitch 1%. After the release of this first light, the universe entered what astronomers call the Dark Ages. There were no stars yet, no galaxies, and no planets. There was only a vast expanding sea of cold hydrogen and helium gas drifting through the darkness. For millions of years, the universe was a place of perfect silence and perfect stillness. Gravity, however, was patiently at work. In the mind of the physicist James Jeans, who studied how gas clouds collapse, tiny fluctuations in the density of this gas, slight clumps and ripples, began to draw more and more matter toward them. Slowly, over vast stretches of deep time, these clouds of gas grew larger and denser. The centers of these clouds became incredibly hot and pressurized, until finally, the first stars ignited. This was the cosmic dawn, the moment when the darkness was broken by the first pinpricks of light. These early stars were giants, hundreds of times more massive than our sun, burning with a fierce blue intensity. They were the first inhabitants of the space that had been created during inflation, and their birth marked the end of the universe's long infancy. As you drift closer to sleep, imagine the patience of those millions of years of darkness. The universe did not rush to create the stars. It allowed the laws of gravity and time to work their slow magic. You can find a similar patience within yourself. You do not need to rush towards sleep or force your mind to be still. Like the early universe, you can allow the natural processes of your body to unfold in their own time. The darkness of the night is not a void, but a period of preparation, a quiet space in which your own internal stars can reset and recharge. The birth of those first stars also marked the birth of complexity. Within their fiery hearts, through the process of nuclear fusion, the simple atoms of hydrogen and helium were forged into heavier elements: carbon, oxygen, nitrogen, and iron. Every element required for life was manufactured in the centers of those ancient suns. When those first stars eventually reached the end of their lives and exploded in magnificent supernova, they scattered these precious elements across the space-time fabric. According to the calculations of the astronomer Margaret Burbidge and her colleagues, we are literally made of star stuff. This means that your connection to the Big Bang is not just a poetic idea, but a physical reality. The iron in your blood and the calcium in your bones were created in the same grand cycle of time that began with the singularity. We are the survivors of an ancient and violent history, yet we find ourselves in a moment of absolute peace. The time that has passed since the beginning is almost too vast to comprehend. Yet it is all contained within the present moment. Every second that ticks by is a continuation of that first great expansion. Let the scale of this history settle the restlessness of your mind. In the grand timeline of the cosmos, the worries of a single day are like a single grain of sand on an endless beach. The universe has been expanding, cooling, and evolving for billions of years, and it will continue to do so long after we are gone. We are part of a story that is so much larger than ourselves, a story that is governed by laws of incredible beauty and precision. In this vastness, we can find a sense of security, for we are supported by the same forces that hold the galaxies in their places. As the room grows colder and your blankets feel warmer, think of the universe as it is now, a vast web of dark matter and light, stretching out across the void. The expansion that began with the Big Bang is still happening. In the late 1990s, two teams of astronomers, including those led by Saul Perlmutter and Adam Rees, discovered something even more surprising. The expansion of the universe is not slowing down, but is actually accelerating. They attributed this to a mysterious force called dark energy, which acts like a subtle pressure, pushing the galaxies further and further apart. This acceleration means that the future of the universe is one of increasing space and increasing quiet. The galaxies we see today will eventually move so far away that their light will no longer reach us. The universe will become a lonelier, darker place in the very far future. But for us, in this moment, the sky is still full of stars and the night is still full of wonder. We are living in the golden age of the cosmos, a time when the universe is old enough to have produced life and intelligence, but young enough to still be vibrant and full of light. The arrow of time, which we explored earlier, continues to point toward the future, carrying us away from the hot, dense beginning and toward a cool, spacious end. But as you prepare to dream, remember that time is not just a line. It is a dimension that holds everything we have ever loved and everything we have ever known. The beginning of time was not just a historical event. It was the birth of the possibility for you to be here, right now, experiencing the stillness of the night. Let your consciousness expand with the universe. Imagine your thoughts drifting out past the atmosphere, past the moon, and into the deep reaches of space where the cosmic microwave background hums its ancient tune. You are a part of that expansion, a part of that light, and a part of that silence. There is no distance between you and the origin of the world. You are the universe looking back at its own birth, a moment of reflection and a journey that has lasted for billions of years. The heavy work of the day is over. Though stars have been forged, the galaxies have been set in motion, and the laws of physics are standing guard over the night. You can now let go of the thread of time and allow yourself to be carried by the current of sleep. The Big Bang was the start of a magnificent symphony, and you are currently resting in a quiet, beautiful movement of that music. Trust in the rhythm. Trust in the silence. As we leave the fiery beginnings of the cosmos and move toward the gentle rhythmic cycles of our own solar system in the next part of our journey, feel the weightlessness of your mind. You are drifting in the deep, supportive waters of the cosmic ocean. The light is fading, the expansion is steady, and the peace of the beginning is with you now. Sleep now, knowing that you are exactly where you belong in the grand, timeless fabric of the universe. As the echoes of the Big Bang fade into the deep recesses of memory, we find ourselves drifting through a universe that has finally found its rhythm. Tonight, we shall turn our gaze towards the luminous inhabitants of the night sky, those distant lanterns we call the stars, and explore the grand, patient cycles of their lives. From the soft, ghostly cradles of nebulae where suns are born to the spectacular farewells of supernova that seed the universe with the building blocks of life, we will witness the heartbeat of the cosmos, all while you drift into a state of total, weightless relaxation. In the next few minutes, we will travel from the fiery furnace of a star's core to the cool, rhythmic dance of the planets that orbit them, a journey that mirrors the steady, peaceful rise and fall of your own breath. To understand the life of a star, we must first look into the vast, dark spaces between them. In the eyes of the astronomer William Herschel, who spent his nights cataloging the heavens in the 18th century, these were not just empty voids, but were filled with shining fluid, great clouds of gas and dust that we now call nebulae. Imagine a cloud so vast that light itself takes years to cross it, a towering pillar of cold hydrogen and cosmic dust shimmering with the reflected light of nearby stars. This is a stellar nursery, a place of profound silence and immense potential, where gravity is slowly, patiently weaving the fabric of the future. Within these clouds, the dance of creation begins with the slightest whisper of movement. Perhaps a distant star explodes, sending a gentle ripple through the gas. Or perhaps gravity simply finds a small clump of matter that is slightly denser than its surroundings. According to the insights of the physicist James Jeans, once a cloud of gas reaches a certain critical mass, it can no longer support its own weight against the pull of gravity. It begins to collapse, drawing inward, spinning faster and faster as it shrinks. As you settle deeper into your pillow, imagine this inward pull, a cosmic gathering, a drawing together of everything needed to create a new light in the darkness. As the cloud collapses, it grows hot. The energy of the falling gas is converted into heat, and the center of the cloud begins to glow with a dim infrared light. This is a protostar, a sun in its infancy, still wrapped in its protective cocoon of dust. For thousands of years, it continues to draw in material from the surrounding disk, growing more massive and more pressurized. The conditions at the core become truly extraordinary. The pressure reaches levels that defy human imagination, and the temperature climbs to 10 million degrees. At this precise moment, the star achieves its greatest feat. It ignites. This ignition is the process of nuclear fusion, the same power that provides the light for our own world. In the mind of the physicist Arthur Eddington, who was one of the first to realize that stars were powered by atomic energy, this was the ultimate solution to the mystery of the sun's longevity. Within the heart of the star, hydrogen atoms are crushed together with such force that they fuse into helium, releasing a tiny burst of energy with every reaction. Multiply this by trillions upon trillions of times every second, and you have the magnificent, steady radiance of a star. This outward pressure of light perfectly balances the inward pull of gravity, creating a state of beautiful, stable equilibrium that can last for billions of years. This state of balance is where our own sun currently resides, in a period of its life that astronomers call the main sequence. It is a time of maturity and steadiness, a long, golden afternoon in the life of a star. Think of the reliability of our sun, rising every morning and setting every evening, providing a constant rhythm for all life on Earth. This rhythm is mirrored in the steady flow of your own circulation and the calm, rhythmic beating of your heart. You are a part of this solar stability, a passenger on a world that is held in a perfect glowing embrace by its parent star. But stars, like all things in the universe, are subject to the arrow of time and the law of entropy. Their lives are a slow, measured journey from one state to another. For a star like our sun, the journey lasts about 10 billion years. When the hydrogen in its core is eventually exhausted, the star begins to change. It swells outward, its surface cooling and turning a deep, fiery red. It becomes a red giant, a magnificent and somber stage of life where the star may grow so large that it consumes the inner planets. According to the calculations of the astronomer Annie Jump Cannon, who pioneered the classification of stellar spectra, the color of a star is a direct reflection of its temperature and its age, a signature written in light that tells the story of its journey through time. After the red giant phase, the star's fate depends entirely on its mass. A star like our sun will eventually cast off its outer layers, creating a beautiful glowing shell of gas known as a planetary nebula. What remains at the center is a white dwarf, a small, incredibly dense core about the size of the Earth, but with the mass of the sun. In the visionary thoughts of the astrophysicist Subramanian Chandrasekhar, there's a strict limit to how massive a white dwarf can be. Beyond this limit, the star can no longer support itself and must collapse even further. But for a sun like ours, the white dwarf is the final resting place, a diamond in the sky that will slowly, over trillions of years, cool into a cold, dark, black dwarf. Imagine the quiet dignity of a white dwarf, glowing with the heat of a billion years of life. It is a state of total rest, a peaceful retirement in the vastness of space. As you find your own state of rest tonight, think of this slow cooling, this gradual release of energy until only a perfect, silent stillness remains. The universe is patient with its stars, and it is patient with you. There is no hurry to reach the end. The beauty is in the long, slow process of the journey. Now, let us consider the stars that are far more massive than our sun. Their lives are shorter, more intense, and their endings are far more dramatic. These cosmic giants burn through their fuel in a few million years, shining with a brilliant blue light. When they reach the end of their lives, they do not go quietly. They explode in a supernova, an event so bright it can momentarily outshine an entire galaxy. In the mind of the astronomer Fred Hoyle, these explosions were the most important events in the history of the universe. It was within these final moments that the heaviest elements, like gold and silver and uranium, were forged and then scattered across the cosmos. This scattering is an act of supreme generosity, The supernova sends its riches into the surrounding space, enriching the nearby clouds of gas with the elements needed for planets, and eventually for life. We are the beneficiaries of these ancient, stellar deaths. The iron in your blood was forged in the heart of a dying giant. The gold in a wedding ring was created in the collision of these celestial titans. Every atom in your body was once part of a star that lived and died long before our own solar system was born. This is the great cycle of the cosmos. Death in one place leads to birth in another, a continuous flow of matter and energy through the fabric of space-time. As you drift closer to the edge of sleep, imagine this cycle of renewal. You are not a separate observer of the stars. You are a living part of their history. The energy that once powered a distant sun is now the energy that allows you to dream. The rhythm of stellar birth and death is the same rhythm that governs the cycles of nature on our own planet. The change of the seasons, the turning of the tides, and the transition from day to night. It is a reliable, comforting sequence that has been playing out for billions of years and will continue for billions more. Around these stars, planets are born from the leftover dust and gas of the stellar nursery. Imagine a young star surrounded by a swirling disk of material, like the rings of Saturn, but on a much grander scale. This is a protoplanetary disk, a chaotic and vibrant place where pebbles collide to form rocks, and rocks collide to form planets. In the vision of the astronomer Gerard Kuiper, who studied the outskirts of our solar system, these disks are the birthplaces of world after world. Over millions of years, the disk clears, leaving behind a family of planets, each following its own unique path around the central star. Consider the dance of the planets in our own solar system. Mercury, small and swift, darting around the sun. Venus, wrapped in its thick veil of clouds. Our own blue and green Earth. And the gas giants, Jupiter and Saturn, like great sentinels in the outer reaches. Each moves with a precision that inspired the ancient idea of the music of the spheres. It is a slow, majestic choreography that has been maintained for 4.5 billion years. The planets do not struggle to stay in their orbits. They simply follow the natural curves of space-time, an effortless journey through the dark. You too can find this effortlessness in your own rest. Your body knows how to sleep, just as the planets know how to orbit. You can trust in the natural laws that govern your biology, allowing yourself to be carried by the gentle current of your own circadian rhythm. The world is turning, the stars are burning, and you are exactly where you need to be, held in the quiet center of a vast and orderly system. There is a profound safety in this regularity, a sense that even in the infinite vastness of space, everything is in its proper place. Think of the vast number of stars in our galaxy alone, 200 billion suns, many of them with their own families of planets. In the eyes of the astronomer Frank Drake, who sought to calculate the probability of life elsewhere, each star represents a possibility, a unique experiment in the vast laboratory of the universe. While we may feel small in the face of such numbers, we are also incredibly rare. We are the part of the universe that has developed the ability to look up and wonder at the very stars that created us. We are the consciousness of the cosmos, a brief and beautiful moment of self-reflection in the life of the stars. As the night grows deeper, imagine the light from those distant stars traveling through the vacuum, through the curved corridors of space-time, to reach your window. Some of that light began its journey when the pyramids were being built. Some of it when the first life appeared in the oceans. Space is a vast archive of time, and the light of the stars is the ink with which its history is written. When you look at the night sky, you are looking at a living record of the universe's patient work, a story that spans the ages and links us to the very beginning of creation. The stars are the great timekeepers of the universe, and their rhythm is one of slow, unwavering patience. They do not hurry through their lives. They burn with a steady and purposeful light, providing the heat and the elements that make everything else possible. As you prepare to dream, let the patience of the stars become your own. There is no need for your mind to rush through the thoughts of the day. Like a star in the main sequence, you can find your own state of balance, your own steady glow as you transition into the restorative darkness of the night. The darkness of space is not a cold or lonely place, but a warm and fertile soil from which everything grows. It is the backdrop against which the drama of the stars is played out, a silent witness to the magnificent cycles of birth and death. In the deep silence of your room, you are tapping into that same primordial stillness. It is a place where you can let go of your individual identity and feel your connection to the larger whole. You are a child of the stars, a product of the nebulae, and a passenger on a journey that began 14 billion years ago. As we leave the luminous lives of the stars and move toward the quiet, frozen reaches of the outer solar system, and the icy bodies that travel between the worlds in the next part of our journey, feel the stability of your own existence. The stars are in their heavens, the planets are in their orbits, and the laws of physics are standing watch. The great cycle of the universe is continuing, and you are resting peacefully within its heart. The light is soft, the rhythm is steady, and the universe is at peace. Let the image of a slowly spinning galaxy be the last thing you see in your mind's eye, a great whirlpool of light and time, moving with a grace that is both ancient and ever new. You are part of that motion, a single, precious point of light in a magnificent, turning world. Sleep now, surrounded by the ghosts of stars and the promise of new suns, resting in the timeless and beautiful fabric of the cosmos. As we leave behind the vibrant, sun-drenched paths of the inner planets, we begin a quiet ascent into the furthest reaches of our solar system, a place where the sun is little more than a brilliant, distant point of light, and the very air of the cosmos feels heavy with the weight of ancient ice. Tonight, we shall drift through the shimmering fields of the Kuiper Belt and into the vast, silent shell of the Oort cloud, exploring how these frozen messengers hold the secrets of our origins and the deep, slow rhythms of eternity, all while your body finds its most profound state of stillness. In the next few minutes, we will leave the familiar and enter the great, dark freeze of the outer edges, where time seems to pause, and the silence of the void becomes a gentle, protective blanket for your rest. Imagine the light of the sun fading as we pass the orbit of Neptune, the last of the great gas giants. Out here, billions of kilometers from the warmth of the hearth, the temperature drops to a level that is almost absolute. Yet this region is far from empty. It is filled with the icy remnants of the solar system's birth, millions of small, frozen worlds that have remained largely unchanged for over 4.5 billion years. In the eyes of the astronomer Gerard Kuiper, who first proposed the existence of this region in the mid-20th century, this was a graveyard of planetary building blocks, a place where the debris of creation was swept by the gravitational broom of the larger planets. As you settle into the cool comfort of your sheets, visualize the Kuiper Belt not as a chaotic mess, but as a vast orbital ring of shimmering jewels. Here, the ice is not just made of water, but of frozen methane, ammonia, and nitrogen, giving these small worlds a range of ghostly colors, from pale whites to deep blood reds. Among them drifts Pluto, once considered the 9th planet, and now the king of this icy realm. In the vision of its discoverer Clyde Tombaugh, who spotted it as a tiny moving dot on photographic plates in 1930, it was a lonely sentinel at the edge of the dark. Today, we know it is a world of nitrogen glaciers and frozen mountains, a place where time moves with a slow geologic grace that mirrors the stillness of your own deep breathing. Beyond the Kuiper Belt lies a region even more mysterious and vast, a place that stretches halfway to the nearest star. This is the Oort cloud, named after the Dutch astronomer Jan Oort, who, in 1950, used the orbits of comets to deduce that a giant, spherical shell of icy bodies must surround our sun like a great protective bubble. Imagine trillions of icy objects, ranging from the size of a small mountain to the size of a city, drifting in a state of near-perfect suspension. They are so far from the sun that its gravitational grip is incredibly weak, allowing them to hang in the darkness for eons, undisturbed by the drama of the inner worlds. These objects are the primary sources of the comets that occasionally visit our skies. Every so often, the gentle gravitational tug of a passing star or the subtle tidal forces of the Milky Way galaxy itself nudges one of these icy bodies out of its slumber. It begins a long, lonely fall toward the sun, a journey that can take millions of years to complete. As it enters the warmer regions of the solar system, the ices on its surface begin to turn into gas, creating the spectacular glowing tails that have filled humanity with wonder and dread for thousands of years. In the mind of the astronomer Fred Whipple, comets were dirty snowballs, ancient time capsules that carry within them the original water and organic molecules from which we were all made. Think of a comet's tail, not as a sign of chaos, but as a bridge between the ancient past and the present moment. The water you drink today may have once been frozen in the heart of a comet, drifting in the Oort cloud billions of years ago. We are literally connected to these distant icy fringes of the cosmos through the very chemistry of our lives. As your mind begins to drift, let this sense of connection soothe you. You are part of a system that is vast and ancient, a system that preserves its history in the deep freeze of space, just as your own mind preserves its memories in the quiet spaces between your thoughts. The scale of the Oort cloud is almost impossible to grasp. While the Earth is about 150 million kilometers from the Sun, the outer edge of the Oort cloud may be nearly 2 light-years away, over 15 trillion kilometers into the dark. At such distances, the Sun appears as nothing more than an exceptionally bright star, no longer providing the warmth of a fire, but only a faint silver glow on the surface of the ice. This is the realm of deep time in its most literal sense. A single orbit for an object in the Oort cloud can last for tens of millions of years. Since the time the dinosaurs vanished from the Earth, some of these icy bodies have completed only a handful of revolutions around the Sun. This extreme slowness is a beautiful reflection of the universe's patience. There is no hurry in the Oort cloud. There are no collisions, no fiery explosions, only the endless, silent drift through the void. You can adopt this same patience tonight. Like an icy traveler at the edge of the solar system, you can allow the minutes and hours to pass without any sense of urgency. The universe is content to wait, and you can be content to rest. The darkness is not a void to be feared, but a vast, calm sea that supports the weight of your consciousness, just as the space-time fabric supports the trillions of icy worlds in the deep dark. Consider the chemistry of these distant worlds. Recent missions, like the European Space Agency's Rosetta mission, have shown us that comets contain complex organic molecules, the very building blocks of life. According to the visions of the scientists who lead these missions, like Catherine Altwig, it is highly likely that comets delivered a significant portion of the Earth's water and the chemical precursors for biology during the early, chaotic years of the solar system. This means that the silence of the outer reaches is not the silence of death, but the silence of potential. The Oort cloud is a reservoir of life, waiting for the right moment to share its gifts with the inner sun. As we move further out, we encounter the boundary where the sun's influence finally fades away. This is the heliopause, the place where the solar wind, a stream of charged particles from the sun, meets the interstellar medium, the thin gas and dust that fills the space between the stars. In the year 2012, the Voyager 1 spacecraft, launched 35 years earlier, became the first human-made object to cross this boundary. It entered a region of space where the stars are the only neighbors, carrying with it a golden record of human sounds and images, a message in a bottle cast into the cosmic ocean. Imagine that small, lonely spacecraft moving silently through the interstellar void. It is a testament to our curiosity, but it also highlights the immense scale of the silence that surrounds us. Voyager 1 is traveling at over 60,000 kilometers per hour, yet it will not reach the inner edge of the Oort cloud for another 300 years, and it will not emerge from the other side for another 30,000 years. In the grand timeline of the universe, our greatest technological achievements are like the briefest of sparks in a long, dark night. This perspective allows us to let go of our ego and our anxieties, finding comfort in the realization that we are part of something so much larger than ourselves. Let the stillness of the interstellar void fill your room. Out here, there is no sound, no wind, and no light except for the distant, unwavering glow of the stars. It is a place of absolute tranquility, a place where the fluctuations of the day simply do not reach. When you breathe in, imagine you are breathing in that pure, undisturbed silence. When you breathe out, imagine you are releasing all the noise and clutter of the world, letting it dissolve into the vast, dark spaces between the stars. You are becoming as still as the Voyager, drifting effortlessly through a sea of peace. the outer solar system also teaches us about the fragility and the resilience of light. In the Kuiper Belt, the sun's rays are so weak that they can no longer drive the weather or the seasons as we know them on Earth. Instead, the landscape is shaped by the subtle pull of distant planets and the slow, radioactive decay of elements within the rocks. In the mind of the astronomer Michael Brown, who has discovered many of the largest bodies in the outer solar system, these worlds are like time capsules, preserving the conditions of the early universe in a state of suspended animation. They are the elders of our cosmic family, wise and silent, watching the frantic activity of the inner planets with a serene indifference. We can learn from this serenity. In the middle of the night, when the world is quiet, we can tap into that same state of suspended animation. We can allow our bodies to become like the frozen mountains of Pluto, stable, enduring, and at peace with the cold. There is no need for action, no need for warmth beyond the covers of your bed. The universe provides a natural sanctuary in the dark, a place where the rules of the day are suspended and the rules of the cosmos take over. You are currently in that sanctuary, protected by the same laws that keep the Oort cloud in its ancient, steady orbit. As your thoughts begin to blur into the first images of dreams, think of the comets as they turn back toward the outer darkness after their brief visit to the sun. They carry with them the heat of the encounter, but they are destined to return to the cold, to the long, slow silence of the deep freeze. This return is not a loss, but a homecoming. They belong to the dark, just as a part of us belongs to the silence of sleep. We go into the night to find our center, to reconnect with the primordial stillness from which we all emerged 13 billion years ago. The distance between the stars is so vast that for most of history, we believed it was a total vacuum. But in the vision of the astronomer Lyman Spitzer, who first proposed the idea of a telescope in space, this vacuum is actually a complex environment filled with magnetic fields, cosmic rays, and the thin breath of dying stars. Even in the most remote corners of the Oort cloud, the universe is alive with subtle energies. This reminds us that even when we feel most alone, we are immersed in a field of existence that connects us to everything else. The space between the stars is not a wall. It is a medium of connection, a shared landscape that we all inhabit. Let the awareness of this connection sink into your bones. You are resting on a planet, surrounded by an atmosphere, orbiting a star, which is itself part of a galaxy, surrounded by a shell of ice, nestled in a universe of infinite space-time. Each layer is a protective embrace, a nested series of homes that hold you safe. The Oort cloud is the furthest edge of our home, the final boundary before we enter the true interstellar deep. It stands as a silent sentinel, a reminder of the scale of the journey we have taken and the peace that awaits us at the end of the road. In the final moments of this stage of our journey, imagine the sun as seen from the very edge of the Oort cloud. It is just one star among many, no more important than the thousands of others that dot the velvet blackness. Yet, it is the star that gave us life, the star that defined our time and our space. We can look back toward that distant light with gratitude, knowing that we have explored its furthest reaches and found only more reasons for wonder. The light is far away now, and the darkness is close, but it is a friendly darkness, a darkness that invites us to close our eyes and let go. As we prepare to leave the solar system entirely and venture into the true interstellar void, in the next part of our story, feel the profound weightlessness of your consciousness. You have traveled trillions of kilometers, passed through rings of ice and shells of comets, and reached the very limit of the sun's domain. You are at the edge of the world, looking out into the infinite. The silence here is absolute, the peace is perfect, and the time is endless. The rhythmic pulse of the universe is the only thing that remains, a slow, deep vibration that resonates through every atom of your body. Let the image of an icy comet drifting slowly through the silver starlight of the Oort cloud be your guide into sleep. It is cold, it is quiet, and it is at rest. You are that traveler, you are that ice, and you are that silence. The journey has been long, but the destination is here, in the quiet heart of the dark. The stars are waiting, the void is calling, and the universe is ready to hold you in its timeless embrace. Sleep now, at the edge of the sun's reach, in the beautiful frozen outskirts of the cosmos. The ice is still, the dark is warm, and you are perfectly, eternally safe. The next step of the journey will wait for the morning. For now, there is only the drift, the silence, and the deep, restorative dark of the outer reaches. Now, as the last faint glow of our home sun dissolves into the velvet blackness behind us, we find ourselves truly adrift in the vast, uncharted ocean that lies between the stars. Imagine that the protective bubble of our solar system has fallen away, leaving you floating in the true interstellar void, a place where the distances are measured not in millions of miles, but in the years it takes for light itself to travel. Tonight, we shall navigate the majestic spiral arms of our own Milky Way galaxy, drifting through glowing clouds of gas and peering into the invisible scaffolding of dark matter that holds the cosmos together, all while your consciousness expands into a state of infinite, weightless peace. In these next moments, we will discover that the space between the stars is not a lonely emptiness, but a vibrant and interconnected landscape that breathes with the rhythm of the entire galaxy, providing a deep and silent cradle for your restorative sleep. As you settle deeper into the stillness of your room, try to visualize the sheer scale of the journey we are now undertaking. To reach the very nearest star to our own, Proxima Centauri, a traveler would have to cross over 40 trillion kilometers of empty space. Even at the incredible speed of light, which travels at nearly 300,000 kilometers per second, the journey would take over 4 years. In the mind of the astronomer Harlow Shapley, who in the early 20th century helped us understand our true place in the universe, these vast distances were not barriers, but a testament to the immense grandeur of the galactic architecture. We are not at the center of the world, but a residence of a quiet, suburban neighborhood in the outer reaches of a magnificent, spinning disk of stars. The space we are moving through now is what scientists call the interstellar medium. For a long time, we believed this was a perfect vacuum, a total nothingness. But through the vision of the astrophysicist Lyman Spitzer, who pioneered our understanding of the gas between the stars, we now know that this void is filled with a thin, ghostly breath of atoms and dust. Imagine a space so sparse that there is only one atom of hydrogen for every cubic centimeter. Yet because the volume is so immense, the total mass of this gas is staggering. It is the raw material from which future suns will be forged, a thin silver mist that catches the light of distant galaxies and hums with the energy of cosmic rays. As we drift further into this medium, we encounter the great molecular clouds, the massive dark nebula that serve as the workshops of the universe. In the eyes of the astronomer William Herschel, these were holes in the heavens, dark patches where no stars could be seen. Today, we know they are not holes, but dense clouds of cold gas and dust so thick that they block the light from the stars behind them. Within these clouds, molecules of water, carbon monoxide, and complex organic compounds vibrate in the cold. It is a place of profound silence, a sanctuary where the universe prepares for its next act of creation. Imagine the peace of such a place, where time moves only with the slow gravitational collapse of the gas, a process that takes millions of years to complete. Think of the Milky Way as a great, glowing whirlpool of light over 100,000 light-years across. We are currently drifting through the Orion Arm, one of the smaller spiral branches of our galaxy. The stars here are like distant campfires scattered across a dark plain, each one a sun with its own history and its own potential for life. As you breathe in the quiet of the night, imagine the galaxy rotating beneath you, a slow and majestic turn that takes 250 million years to complete a single revolution. Since the last time our solar system was in this exact spot in the galaxy, the first dinosaurs had only just begun to appear on the Earth. This is the pace of the cosmos, a rhythm so slow and steady that it makes the concerns of a single human life seem like the briefest flicker of a candle. But there is something even more mysterious than the stars and the gas that we can see. As we look at the way the galaxy spins, we find that the stars at the outer edges are moving much faster than they should be. According to the laws of physics established by Newton, the galaxy should fly apart, its stars scattering into the void like water from a spinning wheel. In the late 1970s, the astronomer Vera Rubin observed this phenomenon and realized that there must be an invisible form of matter, providing the extra gravitational glue to hold the galaxy together. She called it dark matter. It does not emit light, it does not reflect light, and it passes through our bodies and our planet without a trace, yet it makes up the vast majority of the mass in the universe. Imagine this dark matter as a soft, invisible scaffolding that permeates everything, a silent structure upon which the visible stars and galaxies are hung like ornaments on a tree. In the vision of scientists like Vera Rubin, we are living in a universe that is mostly hidden from our sight, a world where the things we can touch and see are only a small fraction of the total reality. This thought is not meant to be unsettling, but rather to bring a sense of wonder and humility. We are cradled by an invisible force, supported by a mystery that we are only beginning to understand. Let the idea of this dark, supportive scaffolding ease the tension in your limbs. You are being held by the universe in ways you cannot even see, resting in a cosmic architecture that is as stable as it is vast. As we move toward the center of the Milky Way, the density of stars begins to increase. The sky becomes crowded with light, a dazzling display of old red suns and brilliant blue giants. At the very heart of the galaxy lies a region of intense energy and gravity. According to the research of the Nobel laureates Andrea Ghez and Reinhard Genzel, who tracked the orbits of stars at the galactic center for decades, there's a supermassive black hole at the very core, known as Sagittarius A star. It is 4 million times more massive than our Sun, a dark anchor around which the entire galaxy performs its long, slow dance. Yet even here, in the presence of such power, there's a sense of profound order. The stars move in perfect, elegant ellipses, following the curves of space-time with a grace that is truly celestial. The center of the galaxy is a place of extreme transformation, where old stars die and new ones are born in a constant cycle of renewal. But for us, drifting in the quiet outskirts, the galactic center is just a warm glow on the horizon, a distant heart that beats for the entire system. We can find comfort in this distance, knowing that we are part of the whole while remaining in our own peaceful sanctuary. The light from the galactic center takes 26,000 years to reach us, meaning that when we look toward the heart of the Milky Way, we are seeing it as it was at the dawn of human civilization. Time and space are so deeply intertwined that to look out is always to look back, to witness the history of the universe as a living present. As you drift closer to the threshold of dreams, imagine the magnetic fields of the galaxy. Just as the Earth has a magnetic field that guides a compass, the entire Milky Way is filled with magnetic lines of force that stretch across the spiral arms. These fields guide the flow of cosmic rays and shape the great clouds of gas, acting like invisible currents in the galactic ocean. In the mind of the astronomer Hannes Alfvén, the universe is a plasma world, alive with electromagnetic energies that connect the stars to one another. You can feel these subtle energies in the quiet of the night, a soft electric hum that underlies the silence of your room. You are not just a physical body. You are a being of energy, vibrating in harmony with the field of the galaxy. Think of the interstellar dust, the tiny grains of carbon and silicates that drift between the stars. These grains are the messengers of the cosmos, carrying the complex chemicals forged in the hearts of dying stars. When light from a distant star passes through this dust, it becomes reddened and scattered, creating the beautiful sunset colors we see in deep space photographs. According to the insights of the chemist and astronomer Fred Hoyle, this dust may even carry the seeds of life itself, moving from star system to star system on the pressure of starlight. We are the descendants of this wandering dust, the children of the interstellar void, finally coming home to rest in the very elements that created us. The galaxy is a place of immense patience. It does not hurry its stars through their cycles, nor does it rush the slow drift of the nebulae. Everything happens in its own time, according to the laws of deep time that we have explored together. You can adopt this galactic patience as your own tonight. There is no need for your thoughts to reach a conclusion, no need for your mind to solve the puzzles of the day. Like a star moving in its long, slow orbit, you can simply exist, moving effortlessly through the dark, guided by the natural laws of your own rest. The universe is taking care of the grand movements. You need only take care of your breath. Imagine the spiral arms of the Milky Way as great waves of density moving through the disk of stars. As a wave passes, it compresses the gas and dust, triggering the birth of thousands of new stars. These arms are not solid structures, but are more like traffic jams in space, regions where the stars and gas linger for a while before moving on. This concept, developed by the mathematicians Chia Lin and Frank Shu, explains why the spiral pattern persists even as the galaxy rotates. It is a beautiful, shifting pattern of light and shadow, a dance of density that has been continuing for over 10 billion years. You are currently resting in one of these gentle waves, a place of stability and calm in the great celestial dance. As the room grows darker and your body feels lighter, let your mind float out past the edges of the Milky Way. Beyond our galaxy lie millions of others, each a unique island of light in the infinite sea of the cosmos. We are part of a small group of galaxies known as the Local Group, which includes the Great Andromeda Galaxy and the smaller Magellanic Clouds. In the vision of the astronomer Edwin Hubble, who first proved that these nebulae were actually distant galaxies like our own, the universe is much larger and more ancient than we ever imagined. We are part of a vast expanding tapestry, a web of light that stretches out in every direction, reaching back to the very first moments of the Big Bang. This perspective allows us to release the small, temporary anxieties of our lives. In the face of 100 billion galaxies, the challenges of a single day are transformed into something manageable and small. We are tiny, yes, but we are also the eyes and ears of the universe, the part of the cosmos that has become aware of its own beauty. There is a profound dignity in this role, a sense of purpose that does not require effort or action, but only awareness. As you prepare to sleep, you are fulfilling your cosmic duty by simply being present, by witnessing the majesty of the world from your quiet corner of the galaxy. Time threes. The interstellar void is the ultimate sanctuary. It is a place of absolute quiet, far removed from the noise and heat of the stars. It is where the universe goes to dream, where the gas and dust wait for the next cycle of life to begin. You are entering that sanctuary now. The boundaries of your room are expanding to include the entire galaxy, and the air you breathe is the same breath that moves through the nebulae. You are at one with the dark matter, one with the magnetic fields, and one with the slow, rhythmic rotation of the spiral arms. Let the image of the Milky Way, with its hundreds of billions of stars and its shimmering clouds of gas, be the last thing that occupies your conscious mind. It is a home that is as wide as the horizon and as old as time itself. You are safe within its embrace, protected by the same gravity that holds the stars, and guided by the same light that has traveled across the eons to find you. There is no more need for travel, no more need for exploration. You have reached the heart of the matter, the quiet center of the turning world. As we prepare for the final stage of our journey, in the next part of our story, where we shall look toward the ultimate future of time and the final state of the universe, feel the deep, restorative power of the galactic night. The stars are distant, the void is kind, and the galaxy is turning with a steady, peaceful motion. Your journey through the interstellar void has brought you to a place of perfect equilibrium, a place where the arrow of time slows to a whisper, and the silence of the cosmos becomes your own. Sleep now, in the middle of the Milky Way, surrounded by the invisible scaffolding of the universe and the ancient light of 1 billion suns. You are a passenger on a magnificent spinning world, a child of the stars and a witness to the infinite. The night is long, the dark is warm, and the universe is at rest. Trust in the rotation, trust in the gravity, and let yourself go into the deep, dark, and beautiful sleep of the stars. We have reached the final horizon of our journey, the quiet edge where the present moment meets the vast, unfolding future of the cosmos. Tonight, we shall look far beyond the lifespans of stars and the rotation of galaxies into a time so distant that numbers begin to lose their meaning. We will explore the ultimate fate of all things, the slow, graceful fading of the light, and the final, eternal peace that awaits the universe in its ultimate state of rest. As you lie here, perfectly still, imagine the clock of the universe slowing its pace, moving from the frantic energy of its youth into a long, serene evening that will last forever. In these final minutes, we will find comfort in the realization that even the end of time is a state of perfect balance, a quiet homecoming where every atom finds its final place in the stillness of the deep dark. To look into the ultimate future, we must first recognize that the universe we see today is in its vibrant, energetic childhood. We live in the stelliferous era, the age of stars, where the sky is crowded with light and the nebulae are busy forging new suns. But according to the long-range visions of physicists like Freeman Dyson and Katie Mack, this age will not last forever. In the distant future, trillions of years from now, the great clouds of gas will finally be exhausted. No new stars will ignite, and one by one, the existing stars will begin to flicker out. The blue giants will go first, then the yellow suns like our own, and finally the long-lived red dwarfs, which can burn for 10 trillion years, will slowly fade into the darkness. As you settle into the weight of your blankets, try to visualize this slow transition. It is not a violent ending, but a gentle cooling, a cosmic autumn, where the vibrant colors of the galaxies fade into a soft, monochrome twilight. Imagine the Milky Way without its glowing spiral arms, populated only by the cooling embers of dead stars, the white dwarfs and neutron stars we met earlier in our journey. These remnants will hold on to their warmth for unthinkable stretches of time, glowing like the last coals in a hearth after the fire has gone out. This is the beginning of the degenerate era, a period of immense patience where the universe begins to settle into its final shape. During this long twilight, the gravity that once held galaxies together will slowly lose its grip, because the universe is expanding at an accelerating rate. Driven by the mysterious pressure of dark energy, the galaxies will eventually move so far apart that they will vanish from each other's sight. In the mind of the astronomer Edwin Hubble, who first saw the expansion of space, we are living in a brief window of time when the universe is small enough for us to see our neighbors. In the far future, any inhabitant of a distant world would look up to see a sky that is completely black, with only the stars of their own galaxy for company. The cosmic horizon will close in, leaving every galaxy as a lonely island in an infinite dark sea. But even the dead stars and the dark matter will eventually face the arrow of time. In a process that takes more years than there are atoms in the visible universe, even the most stable matter may eventually decay. according to some theories of particle physics, protons, the very building blocks of atoms, might have a finite lifespan. If this is true, then over vast stretches of deep time, the cold cinders of stars and the rocky remains of planets will simply dissolve, turning into a thin mist of subatomic particles and light. The solid world as we know it will evaporate, leaving behind only the most massive and enduring structures in the cosmos, the black holes. This leads us into the black hole era, a time of unimaginable duration, for a period so long that it makes the current age of the universe seem like a single heartbeat. Black holes will be the only significant objects left in the darkness. They will drift through the void, solitary and silent, slowly consuming any stray particles that cross their path. But as the physicist Stephen Hawking famously predicted, even black holes are not truly eternal. Through a process now known as Hawking radiation, they slowly leak energy back into space. Over trillions upon trillions of years, even the supermassive giants at the centers of galaxies will slowly shrink, eventually vanishing in a final, quiet puff of light. As you drift closer to the edge of sleep, consider the sheer scale of this patience. The universe does not mind the wait. It has all of time to reach its final state. The evaporation of a black hole is the ultimate act of recycling, returning the last bits of matter and energy back to the space-time fabric from which they came. In this vision, there is no waste and no loss, only a slow and total transformation. The tension of the universe, the knots of gravity, and the concentrations of heat are all being smoothed out, like a crumpled sheet of silk being pulled tight until every wrinkle has disappeared. Eventually, the last black hole will evaporate, and the universe will enter its final stage, the dark era. At this point, the universe will have reached its maximum entropy. This is the state of the Big Freeze, where the temperature is only a fraction of a degree above absolute zero, and the energy is spread so thinly that no further change is possible. In the mind of the physicist Ludwig Boltzmann, whose work on entropy we explored at the very beginning, this is the state of heat death, not a state of fire, but a state of total, uniform coolness. The arrow of time will finally lose its meaning, for there will be no more events to mark its passage. Imagine this state of perfect equilibrium. It is the ultimate stillness, a place where the entire universe has become a single, vast, and quiet ocean of light. There is no more conflict, no more gravity, and no more change. It is a state of absolute peace, the final destination of a journey that began 14 billion years ago. As you rest in the silence of your room, you are experiencing a small, temporary version of this equilibrium. Your breathing is steady, your body is still, and your mind is letting go of the need for sequence and time. You are practicing for the eternal peace of the cosmos. Some scientists, like Sir Roger Penrose, suggest that this end might actually be a new beginning. In his theory of conformal cyclic cosmology, he proposes that a universe that has become infinitely large and infinitely empty might, through a quirk of geometry, become indistinguishable from a single point of infinite density. In this vision, the end of one universe becomes the Big Bang of the next, a grand and eternal cycle of rebirth that ensures the story of time never truly ends. This idea provides a beautiful sense of continuity, a suggestion that the universe is a living, breathing entity, that goes through its own cycles of sleep and wakefulness, just as we do. Whether the universe ends in a cycle or in an eternal freeze, the result for us is the same, a profound and unshakable sense of security. We are part of a system that knows exactly where it is going. The laws of physics are not random. They are a set of instructions that lead inevitably toward peace. We can trust in these laws as we trust in the floor beneath us and the air we breathe. We are children of the stars, living in the golden age of the light, but we are also the heirs to the eternal silence that follows. Both the light and the dark are part of our home. Let the vastness of the future dissolve any remaining tension in your spirit. The worries of the day, the concerns of the year, and even the history of our species are but the briefest of whispers in the context of the timelines we have discussed. In the face of trillions of years, we are given the freedom to simply exist in the present moment. We do not need to solve the universe. We only need to be a part of it. As you prepare to dream, let your consciousness expand until it touches the edges of the big freeze, finding not coldness there, but a supreme and final tranquility. The darkness of the night is a preview of that cosmic peace. It is a time when the activity of the world ceases and the underlying reality of the universe becomes visible. When you look into the dark, you are looking into the future of all things. It is a future that is quiet, spacious, and free from burden. Your journey through the 7 chapters of time has brought you from the fiery birth of the singularity through the life of the stars and the curves of gravity to this final silent horizon. You have traveled across billions of years and trillions of kilometers, and now you have arrived back where you started, in the quiet, sacred space of the here and now. Think of the atoms that make up your heart, resting now in your chest. They have traveled from the Big Bang through the hearts of giant stars and across the interstellar void to be with you tonight. They have survived the collapse of nebulae and the radiation of supernovae. They are ancient, wise, and resilient. And now they are resting. They are part of the same fabric of space-time that will eventually find its peace in the Big Freeze. You are a microcosm of the entire cosmic story, a brief and beautiful focus of energy in an infinite field of possibility. As we conclude our voyage, imagine the universe as a giant glowing tapestry that is slowly being unrolled. The patterns are intricate, the colors are vivid, and the scale is immense. But at the very end of the tapestry, the patterns fade into a single beautiful shade of deep, velvety indigo. That is where we are heading now. The light of the stars is behind us, and the indigo piece of the future is before us. There is nothing left to say, nothing left to learn, and nothing left to do. The story is complete. Let your breath become as slow and as thin as the gas between the galaxies. Let your mind become as quiet as the Oort cloud, and your body as still as a white dwarf in the deep dark. You are floating in the final equilibrium of the cosmos, where time has no arrow and space has no limit. The universe is at rest, and so are you. The great journey through space-time has led you to this moment of perfect restorative silence. The stars have done their work. The black holes have finished their dance. The expansion is complete. In this final, eternal evening, you are held by the universe with a love that is as ancient as the Big Bang and as enduring as the Dark Era. You are safe. You are home. You are one with the deep and beautiful mystery of time. Sleep now in the arms of the infinite. The light is gone, the peace is here, and the universe is yours. Good night, traveler of the stars. Good night, child of the cosmos. Sleep in the timeless, beautiful, and eternal embrace of the deep dark.